Okay, so here, let me move along in a thing.
And then there it is. So I guess we can start if people like. Um, our top news story for today is that climate change, driven by volcanic activity, caused the largest mass extinction in the history of the Earth. Our coronavirus story is that a 14-year-old girl wins 25,000 bucks for a scientific breakthrough that could lead to COVID-19 cure. In technology, apparently GM is going to run robot cars in San Francisco without any human backups. In materials, apparently by stacking 2D materials, you can get superconductivity at temperatures you can get in your refrigerator's freezer, with amazing possible applications. And in flight, actual space battles need to be planned well in advance. You can't do it on the shoestring as you go. In environment and agriculture, there's a new recycling system that can transform unwanted garments into new fashion favorites. In biology, apparently, species that work together do better than by cheating. And I can just read. Apparently, we can assimilate and process information better than people could 100 years ago. So we are getting better, but we still start declining at about the age of 35. And in health, apparently active older adults have better physical and mental health. So what's new? Get going. So, Richard, with all of this, what's this about climate change causing the largest mass extinction in the history of the world?
Well, sometimes it's good to know what the past was, so you might get an idea what the future might be. And they have been able to understand now the what happened about 250 million years ago. It was a while back, but and at that time, that was one of the 5 mass extinction events that have happened since life started on this planet. And in this one, about 3/4 of the land life and 95% of the life in the ocean disappeared within a few thousand years. And so the question was, what happened? And they know that it was kicked off by big volcanic eruptions. But after that, they didn't figure out the details until just recently. And this was done by an international team from Germany and Italy and Canada. And to find this out, they studied the shells of fossil brachiopods, which are clam-like organisms that have existed for more than 500 million years. So they studied those in different timelines. And then by measuring different isotopes of boron in the fossil shells, they were able to see how the ocean pH changed over time. And because the ocean's pH is tightly coupled with the CO2 in the atmosphere, that gave them a way to see what happened to the CO2 in the gases on the Earth. And so this is what they understand now is we had the big volcanic explosions. They put a lot of CO2 in the air, and quickly that killed a lot of things in the ocean. But then that killing things in the ocean kicked off a whole series of yet other changes, and there was this domino like collapse of the interconnected life sustaining cycles up and down the food chain on land and sea. And what we have is, the biggest mass extinction ever. This was brought on by CO2, and I would like to avoid it this time.
Any thoughts?
Well, it's not a thought, but it just boggles my mind how, I guess I'm not scientific enough, how people find out that this has happened 500 million years ago and something happened 250 million years ago. It's astounding.
It's absolutely amazing, isn't it?
Yes,
Yeah.
absolutely. And, this is the kind of science that we're capable of doing. And who knows that the isotopes of boron in clamshells, we could use them to tell what the air was like 250 million years ago. Who knew that? These guys.
Well, how do they prove that this is in fact what it is? And the other thing that I had a little problem with is that our epoch. I mean, the time that we're on Earth and making our presence or influence, influencing things is so short as compared to time spans of 500 million years. That I think that we are really rushing things. I imagine towards extinction.
Well, we're number one in climate change. Oh boy. As to how the scientists know these details in the timeline is that as all these critters die in the ocean, they fall to the bottom of the ocean and they make layers. And one of the things that they noticed for a long time is sometimes the changes in these layers were real abrupt. And that's one of these times of mass changes, and they're able to understand it by looking at what was left behind and being very clever guys.
Any other thoughts?
Richard, is this period before or after the asteroid extinction?
This was the event happened, and then which was the CO2 going in the air, and then first a bunch of sea things died, and then over the next 1,000 years, 95% of ocean life and 70% of land life also died. So that happened not immediately, but over a period of 1,000 years. And
Richard, when did this happen relative to when the asteroids hit the Earth, which I assume is about 65 million years ago?
Right, that was 65 million years ago. And again, they first found out it was
about 250 million years ago, right?
Yes.
Uh-huh.
And so this was a bigger one. On the case of the asteroid, this was something external hitting the Earth causing a mass extinction. And this particular one was one that the planet just got to do on its own without outside help.
Any
Thank
other?
you.
If not, let's move on to coronavirus. Apparently, this is 14-year-old girl. She wins $25,000 for a breakthrough that could lead to a COVID cure. Tell us about that.
This one just blows my mind. That again, the setup, the story here is there was a girl. I first thought some high school kid, but then when I read the article more carefully, I found out it was an eighth grader. Okay, so this was the eighth grader. You're seeing her now. Her name is Annika
Nika.
Cheberlou, and she's obviously an Indian American, and she won it for her research project, and her research project was on the computer scanning millions of substances to see if they would fit into a portion of the coronavirus and so maybe attack the coronavirus. And then after this multi-dimensional computer scan of all these things, she identified one excellent candidate for treatment that was unknown to medical science, and they're off working on it now to see if this is in fact a viable treatment. It opens up new doors, and these doors were opened by this 14-year-old Indian American from Texas.
Huh? Any
Yeah.
thoughts about it?
Well, it's an amazing story, and I think, as I remember reading the story, she found a way where whatever she discovered, it attached itself to the coronavirus protein, and made the protein unable to multiply, basically.
Right. Again, it kills it, just exactly the kind of thing that you would want.
Yeah, didn't really kill it. It just enabled or disabled it, so to speak.
Disabling is good enough for me.
Any other thoughts?
What were
Okay.
you doing? Let me just ask before we go on, what were you doing at 14?
Not much.
Not
Anyway,
counting.
okay, so now we can go on.
All right. Now, are you going to go to San Francisco where they're going to run robot cars without human backups? What's that all about?
Well, we're testing. It's what it's about. There are several parts of this story that is interesting to me, and one is that this is not Tesla. This is General Motors. And I had no idea that General Motors has this ongoing autonomous vehicle testing going on in San Francisco. But apparently they do. And it's not just General Motors. There is another company, and the name of the company is Waymo, and it's a unit of Google's parent, Alphabet. So this is Google and their AI thing. And Waymo has an autonomous vehicle hailing service that already is public in the Phoenix area without human drivers. And so this GM company, which is named Cruise, they have reached a point where they think they can safely navigate the streets of San Francisco, which are crazy streets, and they are doing it on a test basis now, and they don't have a date yet for when they're going to turn on actual ride-sharing service in San Francisco, but that's their plan. It's also interesting how they're going about doing it. They're doing it fairly cautiously, and they're going through neighborhood by neighborhood and turning on its ability to navigate in that neighborhood and test it, and at the same time let the people know what they're doing, and they are having meetings in the neighborhood, and they're really trying to establish trust because they understand for this to be used, it has to be things that people trust. And so what they're doing is this careful step-by-step program towards the progress of turning on autonomous driving everywhere. They're making first, though, very sure and very careful testing to make sure it works. And as I say, I've driven the streets of San Francisco, and it was some of the most terrifying urban driving that I've ever done. And so I give them enormous credit for using this as a test case.
Yeah, I was thinking if this is going to be effective, and I have no doubt that it will be over time, it will eliminate the need for taxi drivers and truck drivers and so on and so forth, and it eliminates an awful lot of the work for people. And I wonder what we're going to do with that. And this, of course, not the only thing. Automation in general has already replaced a lot of human effort. And
it's not only the people who are presently drivers that are at risk. If this on-demand car service is really effective and it works, then it means that individuals don't have to own cars. I don't have to own a car. I just have to be able to call one up on my cell phone, and it's there. And so it's not only the drivers, it's the whole transportation industry that this is going to change.
Yeah. So, it would be interesting if we could find something that addresses this problem. The really looming threat of the population is increasing, and at the same time, work opportunities is decreasing, and that's not a very good combination.
Well, I think that means trouble ahead.
I think that autonomous driving is not 100% safe, but neither is driving by humans. So if we plot the two curves, and if more accidents are caused by humans than by autonomous driving, then we should go to autonomous driving. Saves lives.
I'm getting to a place in my life where autonomous driven cars doesn't seem so bad,
No,
Don't you think that we would probably want autonomous driven cars to operate at a higher standard than we do?
I would. Why not?
No, but like normally, we accept that sometimes people do idiotic things. Aren't we very, very worried that machines might do that as well?
Well, again, one of the big autonomous driving tests I think that Tesla was doing, they came to basically a screeching halt 2 years ago because one of their autonomous vehicles had an accident and killed some person. And so they said, we can't release this yet. But that, like Fred was talking about, this was one person. And, there are tens of thousands of people killed every year by human drivers.
It's the same with airbags. There's been lawsuits because airbags have caused accidents. but how many lives have they
Yeah.
saved?
Right.
That's the comparison
Yeah.
we need to do.
I would like them to hover above the cobblestones.
That's good.
They haven't been testing in this neighborhood, that's for sure. We have a lot of streets that have no cobblestones. I mean, instead they're just holes.
Okay.
All
If
right.
we move on to the material story, apparently we have some two-dimensional materials, and you can stack them, and you get real superconductivity at temperatures that are, for us, normal in your fridge's freezer. So with amazing applications, what's this all about, Richard?
This is one of the stories that I think is the kind of developments that really move technology forward. And, you know, we've been talking these last months, one of the regular subjects is 2D materials. And then recently we've been talking about another form of 2D materials, which is stacked 2D materials. And this is a story about the development of stacked 2D materials. So one thing leads to another and leads to another. And before this, they were able to achieve superconductivity with these graphites, but it took a temperature below minus 170 degrees C, which is enormously cold. And because of that, the ability to use this superconductivity was so limited that nobody really did it. And the reason they're pushing for this, one of the reasons, for example, is in technology. In these chips, these tiny computer chips burn energy when they switch and when they transmit the signal from one place to another. And that amount of energy is substantial. Just in the big computer centers around the world, they use about 10% of the electricity on the planet in these big computer systems, and that doesn't even count the stuff we use as individuals. So being able to make chips that function without draining energy is a big deal and changes one of the limits of technology. So that's why they want to do it. And what they found, the first thing they found in studying this is they found the thing that makes superconductivity happen is because oppositely charged particles, one of them are electrons, which we've all heard about, and the other one is holes. And most of you have never heard about holes. Holes are kind of like negative electrons. I had a friend of mine, a brilliant mathematician who studied semiconductor physics, and he said understanding holes was difficult for him. And he said it's kind of like a waterfall going uphill or something. So anyway, electrons in holes, when they can form tightly bound pairs, and those tightly bound pairs are called excitons, and these excitons are the key to superconductivity, it turns out. And what they were able to do using stacked materials is they were able to get by quantum limits of actual just 2D materials, and they stacked them to make 3D materials out of 2D materials. And when they were through with this, they made a superconductor that works at minus what, 3 degrees centigrade. Yeah, minus 3 degrees centigrade. So it's just a little bit below freezing, and it's the kind of temperature that you can get in your freezer. And they are more exciting to really understand now what is going on and how they can manipulate these materials and look for these tightly bound excitons, and they can then, they hope, bring superconductivity up to room temp. And when they can do that, then quickly we can eliminate 20% of the power needed on the planet to run all these stupid computers.
Any thoughts?
I was just wondering, at this point, they still need to refrigerate it. If after they build the equipment and use the energy to refrigerate it, how much do they really save?
Good question. One of the things that in terms of the present applications, one of the things that it means is that one of the places that superconductors are already critical is in the work with fission reactors, because with superconductors you can make superconducting magnets, and these magnets are more powerful than what you had before, and these magnets are what is used to confine temperatures that are higher than the sun in a magnetic bottle. So in the near term, this specific development maybe will make fusion power possible, or more possible than it is now. In the long term, this is just a step along the road to room temp superconductivity. And it's a big step going from minus 170 C to minus 3 degrees C is an enormously easier way to be able to implement it.
Any other thoughts?
Yeah, I was just thinking something like this seems very useful, but also when anybody really can produce the temperatures needed to work with these things, you suppose that somebody might take advantage of it, like terrorists?
Could be. I think the terrorists are going to wait for room temp superconductors because they're not going to be carrying around freezers on their back.
I mean, it just occurs to me that most people have a freezer in their kitchen, and I don't think they carry that particular around. Anyway.
And I'm not sure yet about terrorists' capability of making stacked 2D materials.
Yeah, well.
Okay, moving on to space. Apparently, if you're going to be battling in space, you need to plan well in advance because it isn't all that flexible. You can't roll with the punches. So you have to really think about it before you do it, rather than trying to make things adjust on at the time. Well, what's that about, Richard?
Well, we've all seen, I think, Star Wars movies, and in the Star Wars movie, this guy with this space fighter is there adjusting in real time as all the lasers are shooting at him and stuff. And what they have found out about how we do space war, at least right now, is that it's not going to be that way. Because right now, what you have is these uh, things that are in orbits. And if you're going to do something to affect with this thing in orbit, that other thing that's in orbit, you have to really kind of work it out beforehand, and then it's going to take some time for it to happen. So instead of it being the pow zoom of the Star Wars, it's you are going to take our shot now. Click, we're shot. Now let's go out and have a cup of coffee and dinner and come back to see if we blew up our targets. And so it's not going to be the kind of space wars we envision yet. We got to work on the technology some more.
Any thoughts?
It seems to me that we cannot be sure that it's going to be space wars. I mean, right now we have a virus. It could be a chemical war, it could be a biological war, which could be much more dangerous.
Yes, that's right. I don't think I want you planning our combat.
I won't.
Okay, moving on to the environment. Now, Richard, what's this about? If I've got some clothing that I no longer want, I can make a new fashion thing out of them. Whoa, how do you do that?
Now, this is interesting to me. One of the things is that they're talking about circular processes is one of the kind of buzzword ideas that you see in ecological areas now. And it's circular if, you can take something, make something, use it up, and when you're through with it, then you put it back in the beginning and make some new things. And so this is a company, H&M. I don't know who they are. They have it in the article like it's everybody knows H&M. But H&M has something. They ask, what if an unwanted pair of socks could change the fashion system? They've developed a machine that disassembles and then reassembles old clothes into new ones on the spot. It kind of takes a while, and they've implemented this, the first one already, and customers are able to watch this container-sized machine. So it's big, it's like a big box, and it you put in old clothes and wait around for about 5 hours, so it's not quick, and then some new knitted garment pops out the other end. And while it does it without using water or chemicals. So it's green in that it's circular, and it's clean because it doesn't use the water and the chemicals. And basically, this is what happens. It's an 8-step process. First, then the old garment is sprayed with ozone to remove any microorganisms. Then the garment is shredded, and then the shredded chunks are filtered to remove dirt, and extra virgin material is added, so it's not entirely all recycled. And then they pull slivers of fiber out of this mix after they've straightened it, and then they take multiple fibers and put them together in a string of yarn, and then they make multiple twisted strings of yarn to make what they're going to weave with, and then they put it in an automatic knitting machine and it knits you a garment. Now, I'm afraid if you're going to do this, you're going to have to be satisfied with wearing knits. So I don't want to use it to make new underwear. But other than that, we have now the first of a new kind of technology making clothing as a circular process. And they are licensing this technology to others in the world. So it might be something we actually see somewhere.
Wonder how much energy it takes.
What's that, John?
I wonder how much energy it takes and how that compares to start from scratch, so to speak.
Uh-huh. Good question. And I would hope it takes less energy than it does to do it with new fibers. But certainly that's one of the things that if you're serious about it, that you have to look at the whole equation.
Right.
Yeah.
I think
And
this is
so-
really, I'm sorry.
What's that?
I think it's really exciting because, I mean, I remember reading recently that trying to recycle old clothes was really very, very difficult to do.
It's an
And
enormous problem, yes.
Yeah, and it takes, it takes up an awful lot of space in landfills and whatever, And, some of us hold on to our old clothing long enough so that nobody else would ever want to wear it, take it to Goodwill. No. So, and H&M is really a very innovative company. I think there might be an H&M in Guadalajara. It's an apparel store for young women and men that comes out of Sweden, and we've seen them in lots of countries in Europe, and we have one in Cincinnati.
Okay, wow.
So I'm waiting for hours here in Cincinnati to get this machine, and then I can try it out, right?
Yes, yes. And like you say, the waste problem with used clothes around the planet is an enormous problem. And because of the way that the waste is mixed together, then it presents a problem for dealing with mixed waste also, is you have to be able to figure out what to do with the clothes. And the clothes are a combination of cotton and synthetics, so it's complicated stuff to break down. And think of millions of tons of old socks.
I was listening to the cleaning process that you described.
Yeah.
Okay, moving along, I think a lot of people have the sense that one of the problems with the way the universe works is that people who cheat get ahead. And now, what are you trying to say, Richard? That species that work together do better than those who cheat?
Well, have this kind of liberal viewpoint, and I think from anthropology, I learned that the thing that really marked humans is how well we cooperate with each other. And it turns out it's not just humans, but nature is full of relationships they call mutualisms, that are interactions between species that are beneficial to both. An example of those is, for example, an apple tree and bumblebees. Each get benefit from that relationship, and it has been a part of the animal kingdom for hundreds of millions of years, these different animals cooperating with each other to live. And what was interesting about this particular study is one of the things that happens within these mutualisms is there is how they deal with what they call cheaters. And they have a specific uh, way of identifying cheaters, and that is cheaters are species that steal the benefits of the mutualism without providing anything in return. An example of one of nature's cheaters are nectar robbers. Those are kinds of bees that chew through the backside of the flower to feed on the nectar without coming into contact with the flower parts that result in reproduction. And so if there are too many cheaters, then that natural system doesn't work anymore. And so what they did is they figured out a way to evaluate cheaters and diversity. And they did it with basically microorganisms, yeast. They did it with different kinds of yeast and had a bunch of yeast that had mutual relationships and some yeast that were cheater yeasts, and put them into environments and would see what would happen. And what they found was that in communities that were adequately diverse, then the cheaters basically had little or no effect upon the species that they were cheating from. And it's like having different organisms that could play the particular kind of role in that plant symbiosis, then meant if the cheater was causing a problem, there would be other avenues for the yeast to continue to flourish and reproduce. So what they found here, though this was just in yeast communities, what they found was real solid evidence that says the diverse community can thrive through even periods of heavy cheating activity and still survive and do well. But a community that is not diverse has a lot higher risk of not surviving. One of the reasons I think that this is an interesting story is that on the planet, part of the global warming problem is a loss of ecological diversity. And to me, looking from the small to the big, I sure think we put ourselves at more risk because of the loss of this diversity.
Any other thoughts?
Well, I only wish that the Democrats would stress this idea.
There's apparently several birds that will use another bird's nest
Yes.
to
Yes.
lay the eggs in.
Yes.
I don't know what the other bird that's looking after all these eggs, what they get out of it. I mean, it's just more family to look after.
Right. That does not seem like a mutualism relationship. That seems like a cheater relationship to me.
Richard, it seems to me that the human race is doing very poorly in that area. From the, to quote, cite an example is the Spaniards years ago expelling Muslims from their country and Jews and trying to make everyone the same. The US was an exception for a while, but now they're trying to expel all different elements, which doesn't seem to be very healthy for them. So the human race seems to value getting one over on your neighbor more than cooperation.
Well, I think that's just a recent aberration. And overall, if you look
Well,
at the human race over the millions of years that we and our precursors have been here, it's more marked by cooperating. And there's still many places in the world where you see that every day. You know, when we lived in India, we were close to villages, and what we saw in the villages were the way that people survived is by cooperating. The first thing I heard from a village untouchable man was, "We help each other." I think Fred has seen that in his international work as well.
well, I think that works on a small scale, but you have on the larger scale, you have countries going to war with each other to get more power, to take some power or resources from another country.
Uh-huh.
It's no longer on the personal level, and
Right.
that's where they fall down.
Now, I still think that, you know, we invented farming 10,000 years ago, and when after we invented farming, we invented cities, and then after that, we invented civilization, and it's still all so new that we haven't figured out how to do it very well yet.
Yeah.
Richard, recently you spoke about being at an inflection point right now with the pandemic.
Yes.
That means that after the pandemic is gone, perhaps we will have learned the lessons that working together on a vaccine or just helping each other, is better than what we're doing now.
I hope so. I think that is a possibility, but I, like Phyllis, am not always confident in how smart groups of people are.
Yeah, yeah. When you lose the personal level, then you can pretend it really doesn't, it doesn't affect you.
You can pretend, like you say.
Yeah.
Pretending doesn't make it so.
No, but they can cause an awful lot of harm while they're pretending.
Now we're talking a little bit about morality there, but the next story about us says that if you look at just straight smarts, cognitive ability, the ability to assimilate and process information, we're much smarter than we were 100 years ago. But it isn't all that good. We still lose it all by the time we're after 35. Now, Richard, what's this? What's the story in this?
No, there
We're all
are a couple of stories in this. One of the stories is the story, which is cognitive performance. We're better than we used to be, according to these guys anyway. And the other part of the story is, how come you think you know enough to be able to say that? Now, this is one of these questions about science and how do you know things. And it turns out, we've known for a long time that people's mental capabilities seem to deteriorate as they get older. We've all heard things like that. And, the thing is that science really doesn't know very much about that. And especially they don't know much about the changes over time. And so what these guys did to try to figure out a way to look at the problem is they studied chess games of international competition, master level chess games, which it turns out are well recorded for about the last 125 years. And then the chess games, of course, break down into individual moves. And so they studied 24,000 chess games that had happened in the last 125 years with more than 1.6 million individual moves in the chess games. And somehow, and here they didn't give the secret, but they figured out from the kind of moves that were made in particular situations how cognitively clever the guys moving the chess pieces were. And they felt that they saw this data well enough that they could definitely say the people now, the chess players now, are just smarter than they were 100 years ago. They have greater cognitive ability, and they were able also with this to see at different ages of chess players that they saw that the chess players were getting smarter until they were about 35, and then they weren't getting smarter anymore. And so this is why they could say these things. For the rest of us, though, I would have to say if one continues to exercise one's gray matter regularly, like what we're doing here today, there's a good chance that your brain is just going to keep going.
I agree. I think so. I think they're all wet with that theory. The older I am, the more I feel that I understand things.
That's right. I understand.
I also wonder about the validity of that study you're talking about, because you know, a game like chess, and for that matter, other games like playing bridge, the people have been studying this and writing books on it, and then other people are reading these books because they're all interested in it, and so a lot of smart moves, you know, were not developed by individuals, but rather read in books and then worked on. And so, well, while it looks like maybe somebody is smarter, actually they're just a little better educated.
Well, it's collective wisdom is, I think, what you're talking about. And
That
that's
is correct,
one of the
yeah.
things the species is good about, is remembering things now that happened before. Sometimes we're good at it. Sometimes we ignore it.
Yeah, exactly.
I think our brain, as you know, as time goes by, we're faced with more and more sophisticated problems we have to solve. So I think our brains can continue growing in some ways.
Now, the guys who did this study say that their results suggest that the conditions under which people grow up nowadays, which have this rapid growth of digital technology and all this new stuff, have had a decisive impact upon the cognitive ability of the population at large. That's a bold statement, and I suspect that they better have good science to back them up. Otherwise, they're going to have to watch out for the incoming hand grenades.
Any other comment? Well, if we're not sure about that, what seems to be pretty clear is that if you're active, you can be better both physically and mentally. What's that about?
Now, this is a story, I think this is a story kind of that all of us here live. And so this is not news, but here, this is science. And in the science, basically, what they did on a very wide scale is looked at people and their quality of life. They looked at more than, among other things, about 20 million cancer survivors. And what they found, and general population as well, by the millions. And what they found was, regardless of cancer history, there were big differences around the planet in level of physical and mental health between the most active and the least active. And so if you just compare those two groups, then you see, you have to conclude that continuing to keep moving and continuing to keep our minds working, uh, helps us and benefits us no matter what our condition is or no matter what our age is. So for me, it's just another one of the many stories that say keep physically active, keep mentally active, and however you're doing, you will do as well as you can.
Any comments?
I totally agree.
I have one comment. I think a lot depends on what kind of activity you're involved in. Some studies have shown that for straight fitness, going to the gym is not nearly as beneficial as going to a dancing class. Running marathons 3 or 4 or 5 times a year is detrimental to your health. But physical activity is something like taking a medication, that you absolutely need a certain amount of it, but it's a dosage. And if you get too much of it, it harms. Most of us have the major problem is people don't get enough of it. So they're not up in there. But some of the people who are doing some of the extreme sports, the amount of blood that flows through your system, if you're pushing it all the time, the only way you can get that amount of blood going through it is by enlarging your organs. And that has real problems. So I just sent a thing to my son, who's been running a lot of marathons, saying, maybe you need to look at this. But I don't know that in the long run, that's nearly as healthy as if you were to go to a dance class or something like that, where you're not nearly as strenuous, but you're doing it all the time. Any thoughts on that?
Well, certainly. Last week we had a story that said for those old folks that are sedentary, even standing up for 30 minutes a day is going to benefit your health. So I think we have a curve. That's the low end, and somewhere is the high end. And what your story talks about, Fred, is with all of these things, there's some happy medium between not enough and too much.
Yes.
And I don't think in this group you have to worry much about the effects of repeated ultramarathon runners.
Yes, but the other thing with this is that it's apparently very, very important that you do some of these things with other people. That the socializing is just as important as the activity itself.
I'm sure you're right.
I think
certainly, we're a social animal.
I'd like to talk about this from two points of view. One, Fred, that you brought out something that I had overlooked, and that is the intensity of the activity.
Right.
Some activity is good, for a certain level, but I know that I've gone to the gym. I'd gone to the gym for years, and I've been very moderate. And some people go and they just attack it, and they hurt themselves. And then they don't come anymore. So moderation is definitely the secret. The second thing is that we can't avoid knowing that when we were in our 20s, we were in better physical shape than we are now. Things just wear out. We can maintain good physical health, but I don't think we're going to get any better than we were in our 20s.
Any other thoughts?
I think it's a multifactorial problem. It's not just exercise. It's socialization. It's diet. It's got many factors, concomitant together that make you healthy and mobile. You don't smoke, you don't drink too much, so exercise is just one component of it. I personally, if I had my life to live over again, I'd started yoga at 4 and ate nothing but vegetables and exercise like a madman. So,
Any other thoughts? Okay, then, Richard. Well, thanks again, and we'll see you all next week.
And remember, what
Right.
you're doing here is the a portion of the mental exercise that you need to do each week to keep fit and be
Richard,
happy.
I am already much smarter than I was an hour ago.
All right.
thank you for putting together all the information that you guys accumulate to be able to read and think over. It's a big chore, and thank you for doing that.
Well, it's a
Yes.
labor of love. And it's also, first I do it for myself. If I have to send it to you guys, it means I have to do it. And having that feeling, that obligation keeps me going. And then as I keep doing it, it's all this stuff is interesting
Yeah.
and it just keeps coming. I thought when I first started it, what's going to happen when I run out of news? But I haven't.
Well, I'm grateful for one, for what you're doing. And I want to mention Fred, the wife's presentation was a Sunday. It's nothing short of excellent.
Thank you.
Okay.
Yes, she was excellent.
Okay, very good.
All right.
Thank you,
All right.
everybody.
All the best, folks.
See you next week.
Thank
See you
you.
next week.
Thank
Bye.
you.
Well,
We can move
Yeah.
on.